For years, no matter how realistic my sim looked, it still sounded like a computer, not a real airplane. The first time you fly a real Cessna 172, the noise is what hits you. I spent about 20 hours training in one. Inside a real cockpit, it's loud, about the level of a loud motorcycle. But it isn't just background noise, it's information. Engine RPMs, how the wind is hitting the aircraft, motion rattles, and tire contact. My sim had realistic flight controls, replica avionics, and a wide monitor, but the sound never kept up. I didn't need it to be as loud as a real airplane, but I did want it to be more realistic, to convey the underlying sound cues about what the plane was doing. So I set out to fix that. I assumed the fix would just be good headphones or better speakers. It wasn't. At every step, the answer turned out to be configuration and tuning, not just something I simply bought. And the thing that finally made it all work great together, I didn't see coming. Over time, I fixed the obvious realism gaps in my sim with replica hardware and better graphics. But it still didn't match my memory of flying a real Cessna. It was only when I imagined myself back in the left seat of that first lesson, remembering everything I was hearing and feeling, that the missing piece clicked. It was the sound. When you fly in an airliner, sound just doesn't feel that important. It's mostly just white noise, the same monotony for hours. So it's fair to assume sound isn't a big part of flying. A small airplane is nothing like that. The sound is constant, physical, and full of information. It tells you what the engine and propeller are doing and how the air around you is flowing. That's a big part of the realism I was missing. And almost nobody builds for it, because a real cockpit is genuinely loud. And you'd probably never want to reproduce that full loudness at home. So it's easy to assume realistic sim audio just isn't possible or meaningful. It's tempting to believe that if you turn it down, it naturally sounds like a game and that's all there is to it. But loudness was never the point. Many high-quality sim aircraft builders spend enormous effort recording real aircraft sounds and building them into their airplanes. I don't need rock concert level volume to hear good sound quality. It's the nuances that come out with good audio hardware that's important and engaging to me. I enjoy audiophile quality sound, and that's what I set out to achieve in the sim. The first thing I reached for was a good pair of audiophile headphones I already had. Nothing to mount, no extra space. You'd think good headphones would sound more like a real airplane, but with headphones it sounds like the engine is almost surrounding you. In a real aircraft, the engine isn't inside your head. It's out in front of you in the airframe, and you feel it as much as you hear it. Headphones can't do that. No matter how good they are, they take a space you're supposed to be sitting in and collapse it down right next to your ears with no deep feeling of vibration. Good headphones can be a reasonable compromise, but I wanted speakers in order to get true depth, and I needed them to be at ear height, which complicated the setup. Most desktop speakers sit low and aim up at you. The manufacturer of my speaker says the optimal height is level with your ears and pointed directly at you. I put the speakers one on each side of my monitor, about 3 feet away and at about a 30-degree angle to each side. I mounted them to the sim rig itself on VESA brackets with SimLab monitor arms so they stay attached and move with it. The swinging monitor arms allow me to precisely angle them toward me for optimal placement. The brand I chose for them is where I went all in. I bought small but extremely high-quality Genelec 8010A studio monitor speakers. This is the entry level for a line of larger speakers that is one of the top brands used in high-end audio recording studios. But the reason matters more than the brand. A normal consumer speaker is tuned to flatter the audio. It adds a little warmth and a little extra bass to make music sound pleasant. A studio monitor is the opposite. It's designed to reproduce sound honestly instead of flattering it. And Genelec speakers are renowned for their high level of accuracy and transparency. Honesty is what you want for sim realism. With them, the airplane now had a proper sound to it, but the sound had no weight. Powerful low frequencies were the next problem. A real engine has a low end you feel in your chest, and speakers the size of mine can't produce those lows. Small speakers are often built that way on purpose, meant to pair with a matching subwoofer. The natural choice was the matching Genelec 7040A subwoofer with a built-in audio crossover at 85 Hz designed specifically for the 8010A speakers. I understood the concept on paper and it sounded compelling, but I didn't really appreciate it until I heard it. I'd always thought of subwoofers the way home theater often treats them, to give it more powerful and dramatic bass. But a studio subwoofer's job isn't to add drama. Its job is to take the very lowest frequencies off the main speakers so they can stay precise. That handoff has to be tuned carefully, and when it's right, you stop noticing the subwoofer at all. It disappears. What you notice instead is that everything else gets cleaner. So the in-flight experience was dramatically better with the subwoofer and its precise crossover frequencies. But there were the smaller, less dramatic phases of flight that still didn't sound quite right. During pre-flight especially, you're flipping switches, turning on the fuel pump, the gyros start spinning up. That's part of the realism and fun too. But when I did the pre-flight, individual noises still sounded vague and not quite precisely located, and it took some digging to understand and fix that. The missing piece, the spatial location of cockpit panel sounds, turned out to be the most challenging part of the whole audio upgrade. In my sim, the seat sits to the left of the center line, the way a real GA pilot sits. So my left speaker is about a foot closer to my head than my right one. Ideally, I would be sitting right in the middle, but that wasn't physically possible in my setup. I had adjusted the volume balance so it sounded like the left and right speakers were equally far away and I was centered. But something still sounded muddy with the quiet switch clicks, and they floated in space. It took me a while to understand what was actually happening. The problem was never balanced volume. It was time. Because of the placement, sound from the closer speaker reached my ear slightly earlier than the farther one. Your brain uses that tiny timing difference to work out where the sound is coming from. Turning the volume down doesn't fix that. Your brain is still getting mixed signals about where things are. What fixes it is delay. You delay the sound from the closer speaker by that tiny amount of time, in my case about 800 microseconds, but that depends on the distance difference. When you do that, the corresponding sounds from both speakers reach your ear together. It sounds tiny, but it makes a big perceptual difference. I bought an external hardware digital signal processor, the Mini DSP Flex, to set the appropriate delay between channels. There are free software-only DSPs that do similar things, but I found them to be harder to configure than the dedicated DSP hardware. The moment I got it right, every tiny sound from the cockpit panel snapped into its proper place. Kind of like the way you can isolate the location of individual symphony musicians when you listen to classical music on a properly tuned stereo setup. In my setup, speakers couldn't alone fix the problem. But good speakers and proper delay compound the benefit of each one individually. It was understanding the interaction of the components as a system and how they were shaping the experience that mattered. I had largely solved the audible problems, but I still hadn't fully solved the feel problem. In a real airplane, you don't just hear the engine, you feel it. It comes up through the floor, the seat, and the controls. That was the part I was still missing. With a precise rather than boomy subwoofer, there wasn't a lot of exaggerated deep vibration. Simmers usually chase this with something that shakes the seat. My first try was a haptic gaming pad, the kind built to rumble your chair. It's similar in effect to the well-known butt-kicker haptic transducers, but it didn't feel right. It gave the deep, heavy rumble you'd want for a movie explosion, but a Cessna doesn't rumble like that. The engine sounds more like a loud lawnmower than a volcano. The haptic pad was providing drama when what I needed was texture. What actually worked was an audio tactile transducer, a small Clark synthesis unit bolted to the rig frame under the seat. It turns the engine's low end into both sound and vibration you feel through the frame and also hear. The haptic pad and butt kicker can't really achieve this same compound effect because of the limited frequencies they operate at and their physical design. I drive the audio transducer with a small dedicated 235-watt Fozzy ZA3 amp attached to the rig. But even the tamer transducer was too much at first. I narrowed it to just the engine's hum, not deep rumble, using the equalizer and filter settings in the Mini DSP Flex that feeds the Fozzy amp. Once I did that, it stopped feeling like a gaming chair. It started feeling like an airframe, a tactile hum under everything, the way the floor of a real cockpit feels. The subwoofer didn't need to provide the vibration, it provided the low-end depth, and the transducer provided the feel. With all that locked in, I assumed that had to be the finish line. Then I ended up getting a VR headset. When I put it on, I realized I had been missing something obvious about audio the whole time. I built this entire audio system before I owned a VR headset. When I finally got one, a Pimax Crystal Super, I expected its sound to be a problem. My Pimax headset has small speakers built into it close to your ears. I assumed I would have to choose the headset's audio or the system I had just spent months building. But that wasn't what happened. The headset gave me something I didn't have before, a second separate place to put sound. The headset has DMAS mini speakers placed an inch or so from your ears and in open air. In a real cockpit, the radio doesn't come from the airframe. It comes from inside your headset close to your ears while you are wearing an aviation headset. The engine comes from the airplane around you. Two different kinds of sound from two different places. I started routing air traffic control through the headset close in the way a real aviation headset feels, and I left the rest of the sounds on the speakers and transducer. The radio became close and intimate. The airplane stayed big and all around me with precise sound location isolation. And the reduced volume I was using for the Genelec speakers was no longer a liability. It matched the level of the cockpit sounds to be similar to what you hear while wearing a noise-canceling aviation headset. That was the moment the sim stopped being a screen with good speakers. It became incredibly close to the real thing. I wasn't listening to an airplane anymore. I was sitting inside one. Not one piece of that final step was about sound quality. It was about where each sound belonged with the level, balance, and depth of the real thing. And the immersive visuals of the VR headset completed the sensory surround. When I started, I thought better sound just meant better gear, headphones or speakers. By the end, I had learned that it was much more than just that. I did go all in on the gear. Studio monitors, a matched subwoofer, dedicated DSP, audio transducer, the whole chain. And a VR headset with separate close-in audio. I went deep because realism is an important part of this hobby I genuinely enjoy, and I wanted to see if I could take it further with audio. But this reinforced a lesson I'd learned in other parts of my sim building journey. What mattered was how all the parts worked together and how carefully they were tuned as a unified system. And not surprisingly, the same principles come into play when designing high-end home theater systems as well. Speaker placement and angle, crossover frequencies, delay, and coherent soundstage separation all matter. When you set up a high-end sim like this and couple it with VR, you feel like you are truly sitting inside a cockpit, not flying a computer. Sim flying is genuinely entertaining, but for me, it's also about realism. The combination of studio-grade transparent monitors, realistic vibration, and precise soundstage is ultimately what delivers that audio realism. The realism doesn't take away from the entertainment, it adds to it. If you've thought about upgrading your own Sims audio, or you've already changed something and it surprised you, I'd like to hear about it in the comments. If you found any of this useful, please consider liking and subscribing. It really helps my channel grow. Thanks for watching, and happy simming.